So question 4 is an old question. It probably comes from 2019 or thereabouts. It was probably on a mock paper or a sample paper of some sort. Anyway, it is a kinematics question. So the velocity of a particle in meters per second is given by v of t is equal to e to the 2t on 2 minus 5t minus a half. And then it asks a few questions about determine the velocity of the particle after 2 seconds, the acceleration of the particle after 2 seconds, and when the acceleration is positive. Now, my approach with my students is always to say, okay, whenever you're in a tech active question and they give you a function, put it straight in the calculator. Now that would be not necessarily in a multiple choice question, but you might. But certainly whenever there's a few marks going, it would be recommended. Now, so what I'm doing is I'm entering that in. So fraction I want, and that would be e to the power of 2 x. Hold on, x is certainly that one there. Not sure where I got that x there from, so I'll have to delete that. And that was on 2, subtract 5x, subtract 1/2. I could put 0.5 there, but I tend to put it exactly the way it is, so it's easy to check. I can actually tell whether I've got the right thing. So pretty much that's done. That's the function. And if we go now there's, of course, we're after the velocity of the particle after 2 seconds. That would basically mean calculate the value of that function when t is, or in this case, when x is 2. So now my sense of this question is too that I don't actually need to show any substitution. I am putting 2 in as the t value. However, I don't have to explain what the calculator is doing, and this is a tech active question. So I can simply say, okay, let's calculate. Hold on, is that what I want? I could graph it. That'd certainly be one thing I might do. In fact, creating the window slightly differently. If I were to say, okay, -2 is going to be enough there, and 4 is probably enough there. X scale certainly is 1. Then -3 will probably do the job, and 4. And if we were to graph that, it looks like that. Yeah, so I mean, because that's just a reflection of what we're looking at. Not that helpful at this point, but anyway, let's go. If we actually went to second calculate, I'm after the value of the function. So I'm just going to say, okay, the value of the function when x is 2, and it comes back and says it's 16.7999, which of course rounds to 16.80. Now, notice my answer actually contains a lot in it. I think the answer is in meters per second. The correct value is 16.80 to 2 decimal places. This is an approximation. And also, I'm substituting 2 in as the t value in that function that was given at the start of the question. So it's v of 2. Now, that's sufficient information to communicate what's happened and what the answer is. A little bit tough in this question because back in the day, it was worth 9 marks. We didn't know how many marks were going for the question, but anyway, that's where we're up to. Now, if we look at the second one, it says the acceleration of the particle. Now, many students are tempted to think they need to differentiate, but this is a tech active question, and their calculator will actually determine the value at a certain point. So it'll determine the gradient at a point. And so that's indeed what's appropriate in this situation. So second calculate, and if we then go to 6, which is dy dx, and the x value is 2, so then comes back with 49.598, which of course is 49.60. That's in meters per second per second. It is the value of v dash 2, because the acceleration, of course, is the derivative of the velocity, which is the point of writing that, and it is an approximation. Now, if we go on then to the next question where it says, when is the acceleration positive? Now, for some students, it's very simple. All I have to do at this point is say, oh, okay, I know where now what's happening there. So if I went back and said, okay, where is the minimum turning point in this? Now the left bound certainly would be 0. The right bound could easily be 2, and 1 is my first guess. And so it comes back with 0.8047. Now, the fact that that is 0.8047, the x value, determines the answer to the question, because for many students, on the right-hand side of that point, the gradient is always positive after that. Now, the gradient of the velocity function is in fact the acceleration, so it would seem that that was the sensible way to do it. But I did want to actually go to something else, just because for some people that might be uncomfortable, and I also wanted to reveal something else about what might happen here. Simply a drawing of that showing the minimum turning point and then turning around and saying what the answer was would be sufficient there. But if instead we go back to y equals, it's possible to actually get the calculator to determine the derivative function. Now it's not doing it, so we can't ask it to differentiate. It's not going to do that. But we could go to math and say, okay, we want the derivative at a point. Now that's slightly crazy because we don't want it actually at a point, but I'll come to that in a moment. Now if I say, oh, okay, alpha f4, okay, that's y1. So I'm saying, okay, the function I want the derivative of is y1. The particular point I want it at, I'm going to say x because I want it at all points. And I'm accepting that. Now, of course, if we turn on the graph, then we get the derivative function shows up as well. And it's even possible to go back here and say, well, hold on a minute, I don't need that thing to show up. Now, when I say I don't need to show up, and I need it, but I don't need it to show up in the picture. So if I then go back to the graph, it's just like that. Now, this is a graph of the derivative. It's a graph of the acceleration, and it will be positive whenever it's above the x-axis. So that point there would actually be the point that I'm looking for. So if I said second, calculate that, and it was when the function is 0, so it's option 2. The left bound certainly would be 0. The right bound would be 1. And a guess would be 0.5 or 0.8 or whatever. Yeah. And of course, 0.804786 is the point we're looking for. So notice in my answer, that's actually how I recorded it. So I'm communicating that I found the derivative function on my calculator. That point there is 0.8047, which means that the time is greater than 0.805 seconds. Okay, so that covers that. And that this is a tech active question. It's reasonable that the students will actually engage with it in a tech active way. Now, next question I wanted to go to. This one's an absolute gem. Well, it was for me, and certainly because what the marking guide did for me was taught me something about how to use the cosine rule, but also how to basically do tech active as well. This dates from 2020, so it's an old question, but a goodie, just the same. And it starts out, the diagram shows that the quadrilateral ABCD determine the perimeter of the quadrilateral. Well, essentially the task is, if you can find out how long this side DC is, then you're going to be able to find the perimeter because it just goes all the way around. I wanted to now go to the solution. Now, in particular, I want to kind of draw your attention to something in the diagram. So I'm going to look at the diagram to start with. For many students, the only way out of this is to find the length of BD, and for me, it's the same. I'm finding the length of BD. However, I want to be able to call it something easily. So I'm actually going to call it X. That makes it much more straightforward to talk about. Um, and then, of course, the length I'm actually looking for is y, which is this one over here. But by writing on the diagram, I'm able to define the variables that I'm actually doing or using. Now, defining variables is an important issue when you're actually solving problems. But the diagram does everything in this situation. So draw the line in, and there's no need to say that you drew the line in. I mean, it's obvious that you drew it in because you drew it. And of course, X is what I'm looking for initially, anyway. Now, I then said I'm actually going to apply the cosine rule. Now, the thing to recognize in this triangle now is I know three sides, either because I know them or because I'm looking for them, one or the other, and that I know this angle as well. So all those three bits, all those four bits of information line up with the cosine rule. So I'll say here that I'm using the cosine rule. Absolutely no need to state what it is because it is on the formula sheet, and the QTAA to start with are not going to award marks for you saying the cosine rule is c squared equals a squared plus b squared minus 2ab cos c, even though it is. It's of no merit in the question, in your solution. What is important, however, is that you show what you did with the cosine rule. And so for me, that means that I'm saying x squared. By the way, notice the x is opposite the 117, and of course the x is opposite the 117. So in the formula, if that's 117, this is x all the way over here. So then I just wrote it all out and said, okay, x squared was equal to 4.1 squared, and did that. Now I want to go to actually executing that on the calculator, but there's an advantage in this question in going straight to the equation solver, as it turns out. And that's what I'm inclined to do. So x squared is equal to 4.1 squared plus 7.6 squared minus 2 times 4.1 times 7.6 times the cosine of 117 now. And so what I notice is the calculator's in radian mode. That's not a problem here, provided you recognize that it is, because it's not going to work if you don't. Now, it's in radian mode. I could go and alter that, but cosine is actually also awake too. If instead I just simply went in and said, so it shows angle here, and said, all right, I'm actually in degrees. So the 117 is actually a degree measure. Uh-oh, something happened there. I touched the wrong thing. I need to quit out of that. Go back to the solver. And I imagine I've actually got the right thing there. Let's just have a look. Yes, that is in fact correct. So I'm saying okay to that. Now it's giving me an X value of 0.8047. So obviously I've been doing something before. I don't care. It's not the calculator's guess as to what X is, because in this calculator I need to make a guess. Now I could leave it at that. That would certainly work. But I'm inclined to give it something that's probably at least close to the correct value. So I'm inclined to say, well, X looks like it's probably 9 or 10, something like that. So let's just put 9 and see what happens. So if we then said, okay, solve that, comes back and says, okay, 10.1421, which I then write down. So notice that in this, even though I'm doing the whole thing in the calculator, you need to show where you're going in the question. It's worth 4 marks. Now, notice I also said here, x is greater than 0. Now, I'm deliberate in doing that because this is the equation I'm trying to solve is quadratic. It's got x squared in it. We'll have 2 solutions. Now, with x squared on the left-hand side, it's just going to be plus or minus 10.142. But the point is, rather than specify what the other solution is, it's simply to say x is greater than 0, and that explains why you haven't acknowledged the other solution. Always when you're solving equations, acknowledge the other solutions if there are any. Unless, of course, you have a way of dictating that, well, they're not a solution. But yeah, they are solutions to this equation. So when you solve, you do get them. Anyway, now on my calculator, it doesn't show up, but that's just a feature of the calculator. I could actually get it to show up if I wanted to. Now, and I'll say a little bit more about that later. Now, if I quit out of that, now x is not lost. So if I actually say, okay, what's x? It says, okay, it's 10.142. So it's still there. Then I went to the next question. Now, this is where the gem showed up for me. In this question, my temptation was because I didn't know, I knew what x was, I knew what that was. I couldn't find out what y was because for me, the cosine rule basically operates with that. I was tempted to use the sine rule to find out what this value was and this angle was, and that was going to be difficult also because I need to find this one first. So a few things to do with the sine rule. But when I read the marking guide, the QCAA said a question where they simply applied the cosine rule again. And what I realized about it is the cosine rule has three sides in it and an angle. The cosine rule just works with all of that information. Now, the x has to be by itself because it's opposite the angle. So I'm saying, okay, x squared is here and 62 degrees is there. And the other two sides are just messed in the middle here. So I'm actually just putting them in. And we should go to that now and see what happens. So if I go back to math and numeric solver, and because we've still got x squared there, this time it's actually 5.4 squared plus alpha y squared minus 2. Now I'm using x and y just exactly the way they are in my setting out. And I think it's smart to do that. I find it easier to concentrate if I'm using the variables that I've got in the question. And that's times alpha y. And then I'm multiplying that by the cosine of, and I'm a slow learner here, it is actually 62 degrees. So I'm going to have to go back and say second angle is actually degrees, and closing the bracket, and that's okay. So now 10.142, of course, is still there. It knows what x is. Y is the one that I'm actually trying to solve. So I'm moving the cursor down onto the y to indicate this is where I'm looking. Now, it looks like it's more than 10.142, so I'm inclined to go for, well, it even looks a lot longer, so I'm inclined to go for 12 maybe or 13 and see what happens. So there's my first guess. Now, it kind of isn't going to matter to a large extent. The guess is simply going to determine how long and which, if there are multiple solutions, shows up. But anyway, if we say solve that, comes back with 11.4866, which looks right to me. Now, I was inclined in this question because this is a quadratic equation, it has y squared in it. There's another solution somewhere, and I need to check and just make sure. It's unlikely this question has two solutions, but because just by the way it's worded, but it's smart to actually look anyway. So I'm inclined to then say, well, okay, let's try something else. So if I put a much smaller number like 3 in there and said, okay, what happens when I solve then? Comes back to this 11 again. Okay, so what happens if I try 0? What does that lead to? Well, as it turns out, the other solution is negative 6.416. It's negative, I don't care. So in fact, I'm then writing y is greater than 0. I'm in trouble here. I need to go back now to the 11 solution I had before. because I need that value. Now, if I quit out of here, the y value, and of course, for some of my students, they're a little bit nervous at this point. They're saying the calculator still knows what y is, to which I'm saying, yes, it does. Um, and then there's a case of just going straight to the perimeter. Now, because I have 11.4866 on the screen, I could just simply press the plus sign and say, okay, plus. It will pull the answer down and say, okay, we want 4.1 plus 7.6 plus 5.4 and execute that. And answer comes out as 28.5866, which I can round to 28.59. Now, in terms of an answer, the answer is in centimeters. It's 28.59 approximately. Um, and that so that's the end of that. Now, is there anything else to say here? Yes, in terms of writing the answer with two decimal places, that's my practice normally. So I normally say to my students, okay, two decimal places, unless you have reason to believe otherwise. In the question itself, they only gave the lengths to one decimal place. So it would seem reasonable in this to say 28.6, but 28.59 is going to cut it as well. Either of those answers is actually going to be correct. So thank you. I'm done on this one.